But I'm Noah Prezant. I think we'll go ahead and get started. I lead the methods and automations team here at Collier Aerospace. And I'm here to talk about a couple things. Traceability in HyperX, what we're doing to make HyperX traceable, how we're trying to give you the tools to understand what it is that HyperX is doing. And then also about what else we do as a methods and automations team. So getting right into it, I'd like to talk about a case study in traceability. Let's say that we wanted to investigate some margins. You might want to do this for any number of reasons. Maybe this is your first time using a method and you don't really know what it does, but you want to try to figure out what it does. Maybe this is a method you're actually pretty familiar with and this margin is suspect. You know, you're like, well, why is that happening? You know, you need to go look at it. Or maybe, regardless of how much you know about this method, the margin is negative, but you really need it to be positive. And so you really want to understand what are the inputs, how sensitive is the margin to those inputs, what do I need to do in order to get this to positive margins. So this one is more of a note for me, but we're going to do a live demo without jostling HDMI cables and talk about this. So what I have here is just one of our sample models, so part of a fuselage, and I have a few negative margins in here. Something I wanted to point out, nobody else had really been talking about, kind of fun new features that we've done with this version of HyperX, but one of the new things is we've got this histogram plot over on the side, so you can actually see over here that we're coloring these bins by telling you how much is in there. This is the thing that people have asked for. Just while I was here, I wanted to point that out. But anyways, we have, it tells me here 13 negative margins. I know the one I want to go look at. So I have that right here. Typically, the first thing I would do is I would look at the analysis results. I've done also, before I get too far into this, I've done all of this with our HyperX solver. This is our new sizing code, new analysis code. All of this analysis happens there. So as part of that, we added these warnings kind of all over to let people know when they're looking at results from the new analysis. So anyways, what I have here is a pretty negative von Mises Hill margin. You can see that here. Typically, if I were trying to investigate this, figure out why this happened, I would first look at the analysis details. This shows us the intermediate values that were computed on the way to getting this margin. You can see I had one already open. And before I get too into this, we've done a few things to make these reports better. These reports have been around for a long time, but we've made them a little bit better. We've done small things, like we made it so that by default you can use Excel's normal sort and filtering. So I could look at just a single value here. That's a small thing. We've also done big things, like we completely overhauled how we track, how we capture, and how we store these details in the background, which allows a couple things. One is it allows categorizing these details. So you can see here that we have these various categories here. We have loads, we have geometry, we have midplane stress. We've just made it easier to read. If you've had to look at these in the past, sometimes these names can get pretty long and cryptic. So we've done this, which is nice. And then we've also standardized. We've made it so that whenever we report out loads, we report out the reference plane. So you can see what reference plane it's at. Whenever we report out allowables, we report out temperature alongside it. We've just tried to make these a lot more consumable to read. The other thing that we've done with this overhaul is we've been able to, the volume of data that you can get is no longer limited on the software side. It's now only limited by the hardware side. So if you have terabytes of space that you wish to store analysis details, you can. So if you want all analysis details for every single element, for every single load case, for every single criteria, every single zone, you can do that now, which used to be a limitation. There was a limit in the number that you could actually get out. So let's see, where do I want to go from here? So I'm looking at this report. I'm trying to understand what this margin is. Maybe I look here, I see, okay, I'm computing a midplane stress, a top stress, a bottom stress. I go over and I see over here in von Mises Hill, we have maybe some variables that I'm not super familiar with. It starts calling them A, B, C, and D. Let me just format these a little nicer. But now I'm confused. What is what is this talking about? What equation do I need to use in order to get these values? Typically, the next thing I would do is I would go over to the HME, the HyperX methods and equations document. You can do that from the same spot. You right-click, you say criterion documentation. And what this shows us, and I'll show both of these side by side in a second, but this shows us the HyperX methods and equations, the document that describes what equations are used to compute this margin. What this document does, well, before I get into that, we've done similar things here, some small things and some big things to make these just better. Some small things are, we took a pass through as we were writing these new solver analysis methods, and we tidied them all up. We got a little bit into typesetting. We made all our headers the same, all our footers the same. We made sure everything has nice links, everything has a nice navigation. And then we've done some big things, like we rewrote all of them so that we can keep the document versioned alongside of the code itself, so that process-wise it's much easier for us to keep these two things in sync. We can't change the code without changing the document, which is something that process-wise was more difficult before. And then let's see, back to our story. If I pull up these two things next to each other, if I'm interested in this equation here, I'm interested in how do we compute A. What I can do is at the back of all of these new HyperX methods and equations documents, we have an analysis detail index. So this is something clever that we can do since we're tracking all this stuff together. But if you're interested in where the equations are for A, you can go to the analysis detail index and you can see the pages that the A variable is referenced on. So you have this index that reports out in the HME which analysis details come with it, which just makes it a lot easier to go back and forth between them, and something that would be very difficult for us to maintain if they weren't tracked all together. So anyways, I can do that. I can click this. I can see A is used on page 7. Great. I can see here that if I want to find A, it's in this equation. It substitutes in for this. And I could type those equations in to Excel, and I could plug in the values, and I could see what happens. This is what people often do when they're trying to understand how these methods work. We went one step further. So oftentimes, you want to just tweak an input. You know, you have all these analysis details, but you want to see, okay, but like what would happen if I changed one of these inputs? How would that affect the result? You can type the equations out, and you can do that. But we added one more feature that I want to talk about. So if I go back to HyperX, and in this case, I'm going to go find that particular method. So this is metal strength on Mises Hill. And we added a new button here. We call it sample calculations. And what this does is it shows us a little form that has very similar inputs and outputs to what we saw previously in the HME and in the methods and equations document. And in the analysis detail report. And it allows you to put in your own inputs and in real time press calculate and see what that does to your outputs. And it shows the equations alongside it. So this is a little more convenient in particular for this A value. It tells you right here what the equation is. And it'll fill this out. You can mess with the inputs. You can see how sensitive the outputs are to that right there. And I want to point out here, this is not like a duplicate of the method. This is another view into the same method. So it's the same analysis code that's running in the background. We're just exposing like another entry point into that method, which is something that you don't get if you're retyping equations into Excel. It's not exactly the same. There's something different there. So yeah.
Did you pre-populate this with a zone example?
So that is something that the right-click menu suggests that you can do. But at this very moment, you can't. Yes, that is the idea, though, that you can right-click here on this particular zone with this particular analysis, and it would go and it would look in the analysis details for that and pull out the inputs and pre-populate this form. That's something that should be there by this release, but at this very moment is not. Yeah, I think if I do this, we get a nice picture. So, yeah. Anyways. Okay, so what makes all this possible? So this is a lot of moving pieces that we're sort of having to keep track of now. And it's really powerful, but it is kind of a lot going on. And so what I wanted to talk about was packages, which is the capability that we've added to HyperX to be able to track all of this, all of our modular capability, and keep everything together. So I have a graphic that I want to get into first, conceptually what is a package, and then we can go back to HyperX. So conceptually, a package is a box. It's a zip file, but what we put into it is anything that HyperX needs in order to keep this capability together. So we'll put into it DLLs. So most of our analysis code ends up being in these libraries. That goes in the package. The HMEs, those are PDFs. Those go into this package. We'll put in change logs. So we've been relatively verbose lately in tracking what has changed between each release of one of our packages. No one has packages yet; they're all internal. But we have been tracking, what changes between each new version that we put out. You can put in associated files, READMEs, something if someone doesn't want to dig through the PDF, but they just want to understand, like, is this for crippling or is this relevant for me? And then the other thing is scripts. You can bundle scripts along. So a lot of times people write criteria. And you need some associated setup script to help run that criteria. Or you can get rid of the criteria altogether and have a package of just scripts. I mean, that's totally fine too. And then all of this, we put a version on. And so this is more of a technical detail, but it's an important one. So the difference between one version and the next is tracked in the changelog, and you can see how those changes sort of propagate over time. I'm going to demonstrate this more with the form, but you stick all these things together, you zip it up, you stick a version number on it, and then that is a package. So, ta-da. Let's see, back to HyperX. So if I'm in here and I want to look at what our packages are, I can go and we have this package manager form. So these three different things here, these three things are each packages themselves. This one, solver criteria. This is all of the criteria that our HyperX solver uses. You can see here the criteria that comes along with it. We have crippling, we have laminate strength, we have whatever else. Metal strength is what we were just looking at. We link documentation. We have HMEs for each one of these. We have change logs for each one of these. And there's really a lot that can be done here. I had a couple points I wanted to make. Let's see, one point is that you can view the versions that you have. So you can choose which particular version of the analysis code you want to run. This is something that previously was available to analysis plugins only, but it's something that we really brought to the forefront here with packages. So the implication here is if you, let's see, if for whatever reason you're stuck on an old version of HyperX, but you want to use new analysis code. You need a new customization, new analysis capability. You want us to add a setting to one of our existing analysis capabilities. That was something that was previously only possible with what we called analysis plugins, but is now possible with all methods, whether we write them or you write them in the solver system. It also works the other way around. So let's say that you want to use the new analysis code. Maybe we make our section cuts a lot better. Sorry, you want to use the new interface code. Let's say we make our section cuts a lot better. You want to use, we've made a bunch of big performance improvements. You want the new interface. But at the same time, we made some updates to our crippling method that you don't really agree with. Hopefully that doesn't happen. But if it did, what you could do is you could stick to the old analysis code and get the new interface code. So you can kind of choose which one you want. Especially if you're tracking down why did my margins change between versions, you have a bit more control in seeing what actually changed. You can choose, let me update the interface, use the old analysis code, see if that does it. Let me change the versions of the analysis code, see what that does. It just gives you more flexibility there. And let's see. So I also just wanted to mention, so this is a tool that we built for ourselves. But I also anticipate this being how you all, if you're distributing scripts or tools within your own companies, would like to do that distribution. It solves a distribution problem for ourselves. So to explain that, if I write a script and it works great for me. I know how it works on my machine, that sort of thing. Maybe I give it to a friend. This friend uses the script, and that's fine. But maybe they give it to some other people, and now cat's kind of out of the bag on that one. And then some time goes by, and I realize, oh, that wasn't quite right. Maybe something should be different. Maybe it was right, but it could be better. Whatever it is, I have some updates that I want to push to all these people who use it, but I don't even know who that is. This can become really difficult. But with something like this, my new suggested workflow would be you write this script. When you want to give it to someone, you put it in a box. You make a package out of it, and you put that in some shared location. And then you tell anyone who wants to use it, you just point to that shared location. It shows up here. If they install it, they'll be able to see, oh, there's an upgrade available. Or maybe if they have automatic upgrades installed, they'll get a new version whenever that new version is put out. And to put out a new version, all you have to do is put a new version on it, make a new box, stick that in the shared location, and then everyone has access to it, which is really convenient for us in-house. That was managing all that internally had become difficult, and if that's something you all have had to manage yourselves, then hopefully that would be helpful as well. Yeah, that is pretty much the only point I wanted to make on that. What else? So what's next? What is next for the Methods and Automations team here at Collier Aerospace? Mostly more. We're doing more of a lot of the same stuff that we have been doing. We're doing more packages. There's a lot more analysis code to write, more analysis methods to bring over from our old system to the new system. There's a lot more modularity that we're hoping to expose, things like loads processing, things like other areas of solver that people might want to customize. New API features. We're kind of constantly working on adding features to our scripting APIs and our analysis method APIs. And not only that, but we're balancing that with stability of our API to make sure that people who code against it can be sure that their code continues to work even after we add new things to it. Traceability is a big thing that we're into that I just talked about today. We're working on adding things like analysis details to more areas of the software. So if you're trying to understand how something like element loads turn into panel loads, to have analysis details for that sort of thing. And we're working on many other things as well. I've got the red light, so I'm going to keep trucking. But the one I wanted to mention was support. So we're doing more support. We do a lot of support right now for many people, but largely our internal engineering services. And we'd like to offer that a little more direct to you all. If that is something that you are interested in, really just keep us in mind. So if you consider to yourself, man, I would really like help running HyperX on some high-performance machine or some cluster, and you don't want necessarily an engineer to do that for you, you just want some tools set up to help you do that. That's the sort of thing that we help with. If you want to sync laminate allowables with HyperX, then we can help make tools for that sort of thing. Automated setup, obviously customizing analysis methods, adding analysis methods, that sort of thing. Feel free to come to us, and we can hopefully help you with what you need. Let's see. So in summary, we've talked about a few things today. We've talked about we've talked about how we've added this new capability called packages. It allows us to keep all these things together, but it also allows you to keep these things together as you develop your own tools. And really, the point I'm trying to hammer home is that we're really trying to give you the capability to understand what HyperX is doing. We're trying to give you those tools, give you that power to be able to do that and understand how HyperX does stress analysis. So, thank you very much. Do you have any questions?
I know, great presentation. Thank you. Lot of great features. I just want to know, so just analysis without sizing. So we have generated a lot of FEM models, a lot of results, a lot of data. It's very hard to keep track of what's in each model. Can the package manager be used almost like standalone just to manage non-hypersizer data files, if you like?
Like as a sub-in for some kind of PLM software?
Yeah, like a data manager for analysts or CA sort of data.
Right. I think that potentially. I think that if you started putting really big files in here, I don't think we really designed it to handle particularly large files. I'm looking in the audience. But, right, no, I was looking for Brian Henry. I was looking for the developer. No, so I probably wouldn't, I think that PLM software would probably be what I would still recommend for trying to do data management. I mean, you definitely could. So things that you could do here is you could include things like FEM models inside a package and then have a script that like does some automated setup if you had, you know, something common that you wanted set up that way. But I think for managing results, I think we have other solutions that would probably be preferred for that. Like our dashboard might be interesting. I think someone's talking about that today if you're trying to manage a lot of results. We do have solutions for that, but I probably wouldn't point you to packages.
Great, thanks.
Where's all the different versions of these packages stored? Are they stored on the website? Like, you know, where is it pulling from? Is it stored locally?
For these ones here, I just have them in a folder. They're stored locally. You could put them on a shared drive. You could put them in a folder locally. We have plans to make a web interface for them so that you could store them on a website and access it somewhat like how you access Python packages with, you know, pip or that sort of thing, or cargo crates or whatever these other packages do. Yeah, but right now it's all just locally, and you point to it. We have a settings form here, so you can point and you tell it where you want it to look for your packages, and it'll go look and see what it finds in there.
So when a new package is developed and released, is that something that y'all will notify the users about, or so that they can download it? You know.
Yeah, that is a great question. So that's something that I think long term we'd really like for the sort of web source to work for, so that instead of pointing just to a folder here, you could point to some website, and that we could push stuff up to there. For now, I mean, yeah, we have like a folder on our public transfers files site that we can upload packages to, and then we would have to tell people to download them and put them locally for themselves.
For traceability and reporting purposes, is there a way to take a picture, snapshots, and report it within the package?
Take a picture.
Like the stress reports, whenever one publishes that, it usually has some images of like generic like methods and equations, but something more particular to the project itself, something we can report specifically on what we're doing. Is there a way to package that into the whole sort of?
Let's see. So you're looking for.
I think there should be like a package file, or file including like your packages. At least on the old version there was, because you could give it file links and it would package it up with it.
I guess I can help answer that. So, yeah, I think James touched on this a little bit, but we're working on a stress reporting feature natively, and one of the requests we've had from customers is, you know, how do you include images kind of in automated fashion into those reports? So one idea is that we do have saved views in the viewport, and the idea is that you can kind of basically have saved views of different plots of results, and that would be a way to basically automatically dump those in the stress reports. So I think that's going to kind of live more on the stress report side in the future.
Okay, interesting. Thank you.
Right. Yeah, okay, great.
What are some of the API things that you guys are planning on putting out in the latest release?
Can I call on an audience member? Yeah. Do we know? I mean, so there's a few things. So if you haven't used HyperX before, I suppose I can talk to it. I was hoping that somebody else would.
I was handed a microphone.
Okay. Well, there's just one thing I want to say. So if you haven't used HyperX before, or the HyperX scripting API before, there's a lot of improvements there compared to Hypersizer. We've done a lot to work with getting IntelliSense into there, getting help context right when you're typing it. You know, it suggests what to do and it tells you what the method does. We do that sort of thing. I don't know if there's any big new features that we've added, but we've made it just a lot more automation capability in general. Steven, I don't know if you wanted to add.
Yeah, I agree with that. I think it's kind of a continuous improvement process for us now that the API is relatively full featured, that we're kind of constantly adding additional things that we're exposing that maybe have been in the software for a little while or are now mature enough to expose in the API. So we usually have a pretty comprehensive change log that we'll publish when we release the version in July. But yeah, I don't think there's any like showstopper, like major points in the API to talk about.
Yeah.
In the scripting API specifically.
Scripting API. I mean, possibly analysis details, possibly just like a lot more ability in the scripts to set up design properties and load properties and analysis properties. You know, we've been adding a lot to that lately, but you've been able to do that for a long time, just fleshing it out really. So. All right. Thank you all very much.